We are going to be discussing generative artificial intelligence and large language models. We are not going to be discussing them in a context of generating smooth code that runs without any errors, and we won't be discussing the doomsday scenarios of them replacing programmers, any other professions taking over the humanity. We will just focus on the basics of trying to understand this topic. I hope that's all right with you. My name is Daria. I come here from Czech Republic, and I've spent last 9 years in the field of AI research, development, and then application. So I've been in the field for quite a while, and long before it has become a sexy topic, and it used to be called statistics at some point in this journey. Now it's basically all over the news, and my professional path in the field has been somewhat counterintuitive, because I started out as a project manager in an R&D privately run lab that was focused on the research of artificial general intelligence, which is like the biggest meta topic in the field, and then has progressed towards applying AI models in the industrial landscape and industrial automation in particular. Then having run into the major bottleneck of the lack of talent, specifically on the Czech market, that led me to becoming one of the founders of a non-profit school for programmers called 42 Prague, which is requalifying people into eventually full-stack software developers within the course of 3 years, completely for free. And this is a part of a global network of schools that's represented here in beautiful Amsterdam by a school called GOTO. So the reason I'm telling you all that is to give you a bit of a background, but also to show that throughout my professional career, I have experienced multiple moments when I was like, okay, this is huge. How do I break it down to little pieces, and how can I do something with it right now? So that's what I'm going to try to focus on today. Here. From the mainstream media, we can get an impression that something incredibly huge has happened in the field of AI R&D over the last year. Like there was nothing, and then boom, we have a lot of generative AI that is all of a sudden extremely smart. And when I try to talk to people, not only from the software development areas, but from different professional fields, I have sometimes an impression that this is something that they imagine behind the generative AI and large language models, right? That there is a group of people that are creating some sort of intelligence, pre-programming something as a platform, then they're feeding it with reliable data, and boom, profit is there, the magic is working. Now, today, we'll try to disentangle on why this is not exactly the case, why there is no magic behind the creating intelligence in the beginning, and how large language models are excellent at processing language and working with natural language-related tasks, but are really not suitable for all possible tasks in the future. So, large language models are deep learning models that are essentially pre-trained to generate content, to produce text, to be more specific. And with this impressive ability, they have become the backbone of natural language processing, that has become quite a massive topic over the last years. Large language models are also frequently being referred to as foundational models. These are the models that utilize deep learning in natural language processing and natural language generation tasks. And they do that because they are pre-trained on a large amount of data. Using very specific techniques to this field, such as fine-tuning, in-context learning, one-shot or few-shots learning, these models can be adapted for practical for downstream tasks, and you can see some of the examples over here. They can be pre-trained and fine-tuned to answer specific questions, to do the sentiment analysis of the text, to extract some information, to recognize objects, etc. As to those techniques, 0 means that a model can learn to recognize things it hasn't been specifically seen during training, things it hasn't seen, yeah? Few shots refers to the practice of training model with some input data, but with very minimal amount of data. And traditionally, what we have seen in the landscape is that these large language models have been pre-trained by either academic institutions or big tech companies, such as Microsoft, NVIDIA, OpenAI being a newcomer to that market quite a while ago, but still having access to significant amount of resources at hand. And most of those models, after being pre-trained and prepared, are then available for public use. And this plug-and-play approach sort of is an important step towards large-scale AI adoption, because instead of spending huge resources on training models with generic linguistic knowledge, individuals, companies, and businesses can focus on basically taking what has been created and fine-tuning it for very specific use cases. What's specific about large language models we are seeing right now all over is that those are essentially transformer-based architectures models. The GPT, as a shortcut, stands for Generative Pre-trained Transformer. And transformer is a name of a very specific type of architecture of large language models that has been not exactly discovered, but brought to public back in 2017, so quite a while ago already, definitely before COVID. And that happened in this paper, which was called Attention is All You Need. This is a paper that was created and issued by a group of researchers coming from Google, and they describe a new approach which is characterized by a huge capability of parallelization, meaning these models are able to process incredible amounts of data in parallel at the same time, and this way they are able to sort of generate a prediction of the text that's likely to come next. So you can imagine, in an oversimplification, you can imagine a large language model based on transformer architecture as something that's generating text that is most likely to be the right answer to the question you're putting to the system. Then the sophistication and the performance, the level of accuracy, of statistical probability of that reply is something that can be judged by how many parameters this model has. And the model parameters is the number of factors basically that it's considering when generating its output. That's why what you have definitely also seen over the news, there is now sort of a fight of creating bigger and more powerful large language models competing across the number of parameters. That comes out from the hypothesis that was brought up in that paper, and that basically everything that OpenAI was doing up to the very recent months were trying to prove is that the bigger the better. The more parameters you put in the picture, the more factors you consider, the more compute power and training data you put in the system, the better it becomes. And on a surface level, that seems to be right. Definitely on a consumer and a business level, it has shown great progress, and we will talk about the specific examples and use cases later on. But what I want to highlight is that we have already seen the proof that just making those models bigger does not solve all of the problems. Because there are certain problems that were part of the large language models when they were smaller, when they scaled up, and then now even in the super huge GPT-4, about which we actually, funnily enough, don't even know how many parameters it does have. We still see those problems persisting there. So, large language models can be basically pre-trained with three objectives. One is autoregression, the second one is autoencoding, and then it's sequence to sequence. And the cool, fun, generative tasks that have popularized AI in the last months are conversation, question answering, content generation. Those tasks where the model needs to generate the new text, the new token in the sentence, these are the tasks that are best carried out by autoregressive models, which are currently including everything in the GPT family, as well as a bunch of other open source models. Autoencoding models, which are better suited for the tasks like information extraction, distillation, and some analytical tasks, are now sort of resting in the background, even though they were the ones to make the initial breakthrough in 2017. And for builders, for practitioners, this means that the popular autoregressive models can be used for everything that's connected to content generation. And the more content, the longer the content, the better. However, for analytical tasks, autoregressive LLMs are not the ones which will generate the most satisfying result, and considering different types of models, autoencoding models, or even more traditional NLP methods could be helpful in that case. So summing this up to a very practical output is that autoregression models are something that you see behind the family of GPT large language models. Also, here you can see a brief overview over the most popular large language models, but this is a very dynamic list. So please take this with a grain of salt, because it might happen that in a month, 2 or 3, yeah, this landscape would be completely different. So this is the best of the knowledge up to May of 2023. And even over the last couple of weeks, we have seen some exciting breakthroughs. Now, if it seems like large language models are something extremely new or something that was created in 2017, I'm sorry if I gave you that impression, because that's not fully accurate either. Large language models in different shape or form have actually a very long and not so sophisticated, but quite a long history. Taking it from a step back, you definitely know that artificial intelligence itself as a research field, as a subfield of computer science, has been around since 1950s. Yeah? And this is also roughly the time when the first considerations of how do we approach the tasks of natural language processing and generating natural language, those were the first questions to be addressed. Because when the researchers and scientists working on conceptualizing the field of AI, we're trying to think of like what could be the cool things that humans can do, what could be the actual tasks that we can try to put inside the machine, put into the form of 0 and 1s, to try to imitate something that might work like a human. They obviously bumped into the idea of text and conversation being sort of one of the possible markers of the human intelligence. That also gave, for example, the foundation and the idea of the infamous Turing test, right? Which is about trying to find out if a panel of juries consisting of humans would find out if they are conversing with a real human or with a computer on the other side of the test. This is a very complex and rather philosophical topic, because as you have seen many times in your own lives, having conversation with somebody who appears intelligent just through the speaking, just through the layer of language, does not necessarily mean that that's the case. So language is definitely an important, but not the only judging factor in this whole complexity. But so all of that led to the moment of time back in 1967, when a researcher in MIT named John Weizenbaum has decided to run an experiment and has created the first historical chatbot, so to say, which was based on like a father or mother of something of the large language models that we see nowadays. It was called Eliza, and the name was referring to Pygmalion's story, right? And also to the story of Eliza Doolittle that we see depicted in My Fair Lady, which was about trying to train a model, yeah, or something to converse smoothly in a human language. The purpose of this experiment was to see how humans are going to be interacting with such interfaces. And what Weizenbaum did was essentially very simple if we look at it from our modern perspective. Yeah, he created a very simple conversational interface which would have just a very limited amount of operations available. And it would take, you would put your input there, as in, hi, I'm Daria, I'm having a bad day. And you will receive a variation of replies which would basically rephrase your stuff and add a couple of words on top of that. The goal was to imitate the notion of a therapist conversing to their patient. So I would say, I'm Daria, I'm having a bad day. And the answer would be, Daria, I'm sad that you're having a bad day. Or why are you having a bad day? Yeah. And the whole conversational logic was built within those terms. What Weizenbaum didn't expect was that this moment gave birth to a lot of sociological research afterwards, because now even there is something that's being referred to as Eliza effect, because he could see a lot of people coming from all over MIT trying to converse to Eliza about their personal issues. They did a press release, as the tech universities tend to do when something seems interesting for the general public, and they started receiving letters from all over the US where people would be sharing their own personal stuff with Eliza, asking for an advice. And initially, Weizenbaum was hoping to prove that, these are just silly models. We are far away from actually having something useful. But in the end of this experiment, he actually retired from MIT, didn't return to the field, and said, yeah, well, people will tend to think that something is much more intelligent than it actually is if it's able to converse the ways human does. So in this case, ELIZA was a simple program that was using pattern recognition to simulate human conversation. And despite it being far from perfect, it's being taken as a historical milestone of the first point of research into the natural language processing and development of the more sophisticated large language models. And then over the years, several significant innovations have propelled in the field, and one of the such innovations was the introduction of long short-term memory, or LSTM, networks in 1997, which allowed for the creation of first neural networks, which were a little bit more, well, definitely more sophisticated, and capable of having more significant amounts of data being stored in them and providing some context for the textual conversations. And then another pivotal moment came with Stanford Core NLP suite, which was introduced in 2010, and it provided a set of tools and algorithms that enabled the researchers working in the other fields to also tackle complex NLP tasks such as sentiment analysis and recognition. In 2011, Google Brain was launched, which enabled researchers to have access to powerful computing resources and to the advanced features such as word embeddings that allowed natural language processing systems to better understand the context of word, because the general development was going in a sense of just recognizing one word is enough. You need to understand is not enough, excuse me. You need to understand the context of word a little bit better to generate the result which was more likely to appear more human, so to say. And that leads us to the point where we see that the introduction of the transformer architecture in 2017, which allowed for incredible amount of parallel processing, was something that allowed the systems to go through a lot of context and try to select the most appropriate one. Then the transformer architecture enabled the creation of larger and more sophisticated LLMs. OpenAI have come to the market and joined the race, and in 2023 they launched or made available to public GPT-3, which is sort of, I think, the starting point of the frenzy that we're seeing now all over the market. After that, this year in spring, we saw the release of GPT-4, also coming from OpenAI, and that has been a turning point for the field and for the large language models for various reasons. Well, yeah, first of all, this system had much more parameters, much better capacities for understanding the context, and much better results in generating the output than the previous models. Also, OpenAI, up until that point, used to be the company that was promoting open sharing of information in this field. But with the release of GPT-4, they also have released the documentation, which had nearly 100 pages, but didn't feature any of the technical information, as in how many parameters does this system have, what is the data that it's trained on, how much data was needed, how much of the computing power was needed to do that. And that has put both practitioners and the researchers in a very difficult situation, right? Where we're looking at something big, something interesting, but we don't know what's behind it, if it's proving the hypothesis or otherwise. Another interesting thing with GPT-4 was the release of ChatGPT, which is sort of a conversational interface which allows you to have interactions with that model directly. I'm betting mostly all of you have had your fun trying to interact through ChatGPT. Can I get a brief feel? Yeah, well, I would expect it here, thank you. But so this was, I like to think of it as a moment in history when something, a technology that was previously surrounding us but always hidden under the hood, so to say, yeah? It was in our phones, it was in our car navigation. AI has been everywhere for quite a while, but it was always in this black box and we didn't have a chance to interact with it directly. And then boom, we're looking at the moment when it's becoming a consumer technology, so to say, far from perfect, but getting incredible traction and incredible amount of users interacting with it immediately. And given the context of little context to that release, that's putting us as a society in a difficult but interesting situation. In the absence of data on the topic, it's important to see how can we evaluate that this model is actually smart. Yeah, it's generating text, but how good is text? So one of the interesting moves that OpenAI decided to do in that paper was releasing a set of, they were testing their model against the academic benchmarks, obviously, but they also decided to test this model against the set of traditional exams, the exams that we as humans do in our universities at schools. And they tried it on a variety of exams, starting from lawyer bar exam to the theoretical part of sommelier exam, yeah? And the model has reached very impressive results. Most importantly, if you see the comparison with the previous versions of GPT, yeah, you can also see that the progress from one to another was very, very significant. Now, the mainstream conclusion that one might take out of it is that natural language processing models are smarter than humans. Humans are done. These models are very, very smart. That's really not the case. I'd really like to try to take some time in my talk later on to explain you on why is that. But now that you know how it works, right, that they generate the text that's statistically likely to be true, imagine yourself as a student facing the tasks that you don't know on an exam and trying to, excuse me, but bullshit your way around it, yeah? Generate the text that would somehow look reliable, have some keywords connected to the topic, to get a satisfactory mark to pass the exam. That's how I like to think about what those models are doing. But then also, given that they are focused on the language tasks, the models didn't do well in the technical tasks. They are really not good in maths, for example, because more complex operations require much more memory, and it's just not task which is suited for getting the most probable answer, which looks trustworthy, because, yeah, it might be something else completely. So, as to the exam situation, I also want to add that I think this marks the point where we might realize that the system of exams and the system of traditional education we have as humans is also getting slightly outdated, right? Because there are so many interesting ways to learn skills which are going to be more and more important in our lives, like critical thinking, yeah, the ability to check sources and make our own conclusions. But then if all of that is tested against multiple choice tests for which you can optimize a language model and get impressive results, then I hope it's sort of a wake-up call to try to change the scene a little bit. When we are talking about large language models being traditionally developed by the big players on the market in the beginning, remember, right? We're talking about that mostly in connection with the steep costs of development. Those costs come from two sides, essentially. The cost of development themselves are quite big. Back in 2020, there's very limited data amount about that available in public, of course, unfortunately. But there's a 2020 study from AI21 Labs, which pegged the expenses for developing a text-generating model with 1.5 billion parameters at as much as $1.6 million. And then if you think of the inference, the cost of actually running the model, it's also another drain. And there are estimates of a cost of running GPT-3 on a single AWS instance at a minimum of $87,000 per year, which means it is expensive. It's still not expensive enough to be prohibitive for larger corporations, and that's why now we see a lot of players entering that field. Adobe creating their generative AI systems, et cetera, but it is quite costly for a new player just to come on the market and do something on their own. And also fairly expensive for a company to decide that they want to create their own internal large language model and to develop that. At the same time, what I want you to keep in mind is that the costs are already dropping and are likely to drop significantly because the research and development is going forward, and training and inference costs for a model with comparable performance to GPT-3 have fallen almost 80% since GPT-3's release 2.5 years ago. So now I really think that we can expect that trend to go even further. However, data is being the emerging bottleneck for large language models' performance, because when you're increasing model parameters, when you're making the model bigger, that requires more data, and we can actually get to the point, funnily enough, when we will be running out of training data, because we can assume that GPT-4 is already being given access to the massive amounts of data. And the more important questions coming now, when we don't have the transparency about that, is, are people actually okay with giving access to that data? So by running out of data, I don't mean running out of data generally in the world, but running out of data which would be appropriate for training those models. At the same time, what we can see is that large language models powered businesses are becoming highly profitable. For example, one of the examples are Notion AI, Jasper AI, or a lot of other businesses that start to incorporate that in their business model. And Jasper AI, which generates copywriting with large language models, has this software as a service type of gross margins of 75% plus. So this is a very interesting way of monetizing the potential development in that field. And of course, as something that is being initially brought to us by big companies, by corporations, there is an alternative movement in the field, and there is a lot of open source attempts and efforts and research and development going on to try to make large language models available to public in an open source format. And in short-term, commercial companies with large budgets and access to a lot of computing power have been ahead in the AI race. However, in the long term, even big companies like Google and OpenAI are concerned with the potential of open source AI. Both of those communities have been making progress somewhat independently, but now their advancements are starting to merge. Because what open source community is logically focused on is being more resource efficient, right? Doing more with less. And this is something that can make AI and specifically large language models more affordable and more environmentally sustainable, because this is one more graph that I want to show you just for the content. This is the heaviest carbon emitter by far, GPT-3, and even the relatively more efficient Bloom model took the amount of power to train, which is enough to power the average American home for 41 years. So this is an additional cost behind the inference and the development, which is now bringing the toll to the society. So fingers crossed, and big fan of the open source community trying now to drive the development of those models into a more sustainable direction by all means. And currently there are roughly, well, many, but I estimate roughly 3 ways to make AI more efficient. The first one is using less compute power and memory, and there are new algorithms like flash attention that help reduce the amount of computing and memory needed, which make it faster and more memory efficient. Then it's using fewer parameters, and instead of retraining the whole model weights, parameter efficient fine-tuning sort of identifies the most important points, the most important weights, reducing resource usage while maintaining performance. And finally, by using less training data, by providing more specific data, more specific instructions during training, AI models can learn faster and require less data. This approach is called instruction fine-tuning, and this has been quite successful in narrowing down the training space. But on the other hand, commercial AI offerings are currently more dominant in terms of the output quality because they have larger models, they have more data and longer training times. But concerns here, as I briefly mentioned, are of course governments and regulations, because powerful AI models that are being developed by commercial companies might serve their own objectives, and we might not be able to know that. One interesting aspect of AI development on such scale is the phenomenon of emergence, where the quantitative changes lead to qualitative changes in the behavior. And AI models can acquire unexpected capabilities during the training that were not part of the original scope. And that has happened quite a few times. That is not something metaphysical or the emergence of its own mind, in a sense. It's rather the byproduct of using neural networks at the core of the game, because the whole mechanism is essentially black box, and that can also lead to some interesting results, which is one of the reasons why we cannot certainly say that just increasing the amount of parameters and compute is going to lead to the progress like that. So in this way, it's often recommended to start with commercial AI models to quickly validate the business model of the case you're working on, of a product, and then perhaps transition to open source models to find a way to leverage that. However, this transition can be challenging because different AI models excel in different tasks, and there is a risk that open source models might not then meet the requirements that were originally set based on the use of the commercial big model. But narrowing it down to practical advice, it definitely makes sense to try out and play with the models coming from the big players before investing your time and resources into going into this a little further. This we've seen already. Another thing that we are seeing with the emergence of these large language models are the implications for the builders of apps, of businesses, of software, because now there is a possibility to communicate with large language models, with GPT in particular, via APIs, via different frameworks, via different agents. And on one hand, that boosts the potential of large language models with external data, but also with agency, with the ability to actually do stuff and perform stuff. Because large language models by themselves, they are a tool. They have no agency or the ability to be connected on the internet or performing some sort of tasks. But by merging and plugging in, so to say, LLM into something else that you're building, this can get very interesting. Yeah. But the rise of these frameworks also has the implications for the LLM layer by itself, because it's now hidden under this hood. Yeah, it's hidden behind an additional abstraction, and any abstraction requires very high awareness and discipline in order to be leveraged in a sustainable way. And when developing applications for the production, I mean, I don't have to be the one to tell that to you, because I'm sure that has been a topic over the last days. Yeah, but it's important to follow a structured process where you evaluate things. In this case, where you select a specific large language model which is most suitable for the task at hand. And many companies, even now, many startups calling themselves AI startups, are already now skipping this step, just assuming that what OpenAI has to offer in the GPT framework is the best thing available on the market, which may not always be true. Secondly, when selecting an LLM, it's important to consider the desired behavior of the application. And if the desired behavior is complex and flexible, then the chosen large language model should be capable of performing well, having the high degree of accuracy, and making the right decision from a wide range of options, right? And lastly, once the application is in development, it's crucial to have MLOps, machine learning operations pipeline in place, which will ensure that the large language model, when put into action, does not deviate too much from changing data distributions and user preferences over time, because we're talking about the architecture that is learning things, that is learning from data, and it's important to set processes in place to avoid that, to ensure a robust and continuously optimized operation that wouldn't allow for issues such as modal shift. On top of issues such as modal shift, if you have ever built an AI product, you will know that end users are often very sensible to AI failures, and users are prone to something as a negativity bias. Even if your system achieves a high overall accuracy, which is the case for large language models now, then the occasional but unavoidable errors will be scrutinized with sort of a magnifying glass. With large language models, the situation is different. They do fail like any other AI system, but what's special about them is that they fail in a silent way. The large language model is not going to tell you the output that I generated might be right, but is not necessarily right. It will just keep generating the output which looks like it's true, but it will be your responsibility as a user to actually check for the sources and see how reliable the output is. The linguistic experiment by Noam Chomsky quite a while ago has already shown an example of a sentence, that's grammatically correct, but semantically nonsensical. And this is what we can see now when we're trying to run LLMs against the specific technical tasks, because as we discussed before, that's not always the best way to use it. So fact-checking of large language models is a big topic now, but it also becomes very difficult once we get into the more specialized domains that are the domains of high expertise, which don't allow the margin for error. And then there, the risk of undetected so-called hallucinations is relatively high, especially in the long term. But again, this is a little bit more of a philosophical conversation. Again, what I wanted to bring your attention on is that the failures from the user side, the failures of large language models are silent, because it doesn't indicate what's 100% right, what isn't. And yeah. This way, what are large language models actually good for? These are the tasks that are mostly connected with processing text, surprise, surprise. It's summarizing a lot of information into a brief review, a brief short summary of text, for example. It's simplifying the process of creating content in a particular style. It's very good with working with context in terms of style. So if you want to have text generated that looks like it came from a specific person, from a specific marketing department that has a certain tone of voice. This is your go-to tool. It generally has a lot of potential in automating writing, the manual writing of the content. However, at the current state of the art of large language models, it works most beautifully as a co-ideation tool. Because if you go in with a prompt of help me create 5 different names or 5 different ideas for something, that's where it can bring to you the value. But then the fine-tuning these models into a very specific tone of voice that your company uses in its communication is really a very traumatic task rather than an efficient one. It can improve the response to specific technical queries. It can be very useful as a first line of help in the chatting interfaces and the technical support, for example. And in the visual side of things, it can be good. It is actually very, very good, as you have seen in the last versions of Midjourney and Stable Diffusion. It's very good at creating realistic representations of people. So the tasks like creating prototypes, sketches, are also something that's very compatible with large language models. What it is bad for is the reliability of the content, for the reasons we just spoke about. It doesn't always identify the source of content. Specifically, if we talk about ChatGPT, its data is cut at 2021, so anything that happened after that, it won't tell you that it doesn't know the answer, but it will once again silently generate something that might not be entirely true. But generally, tracking down the sources is something that is on your side as a user's responsibility side. Maths and calculus are difficult due to the contextual memory notion. It can be difficult to understand how to fine-tune the model for the new circumstances. You can basically either try to fine-tune the model itself if you have access, like, for example, for the playground for GPT, but there is a very limited amount of parameters you can change as a user. The different approach, which we'll look at in a little bit, is you can try to use prompting as a tool to do that, but also this is sort of a new land of trial and error, so it can really be very difficult. And then the issues that we face as a society in terms of bias, in terms of unbalanced approach to things, this is obviously projected into the tools we create. Things that you need to keep in mind in terms of the safety of large language models. I feel like I'm doing a bad sort of advertising here, but not only those were the things for which it's bad for, there is also a number of things that you need to keep in mind, and that's obviously sensitive personal and corporate data. You might have seen in the news the cases of lawsuits with Samsung when some of the employees were trying to use ChatGPT for the corrections in their code, and this way has leaked sensitive information outside of the company. In general, for as long as we are talking about those models being under the hood and the ownership of the data being in the hands of a concrete company that has created the large language model, we have very little control over what is the data that we put there. So sort of a safe approach is the less personal and sensitive stuff you put into it, the better. As opposed to the non-API use, the OpenAI API data is currently not used for training purposes, and there are also cases where you can opt out of your data being used for those purposes. But most importantly, the legislation is hopefully now catching up with the situation, seeing how much risks can be created this way. So specifically, EU is now creating the so-called AI Act, which is the regulation a lot concerning those models and identifying the scopes of risks in which certain measures have to be put in place, and the companies have the burden of proving that they have made this effort to make their models compliant and safe. So the last text-heavy slide, and then it's going to be a little bit more light, I promise, is I try to put together a little bit of the general guidelines to my best knowledge up to this very date for the selection and deployment of large language models, which will sum up things we talked about before. Ideally, to align with your downstream tasks that you are now trying to solve with the help of AI or generative AI, the AI team should create sort of a short list of models that are based on the following criteria, which are benchmarking results in the academic literature with a focus on your specific task, that are exploring the alignment between the objective of the task that you're trying to solve and the type of the model, of the large language model that you're looking at, and the previous experience reported for this model and task combination. In general, the large language model trends are emerging, and some of them go again away. Yeah, they're very short-lived in a sense. So when you're using language models, keep an eye on their life cycle and the overall activity in the LLM landscape, and watch out for the opportunities to step up your game, of course. And then, again, in the beginning, it might be a good idea to experiment with something that's already available. While those models have this amazing human-like ability to produce language, their overall cognitive power is again, not really comparable to anything we think about when we think about humans, because their reasoning capabilities are limited to the information that they find on the surface of the language level. Yeah, so if you're building an application that relies on generating up-to-date or even original knowledge, consider if LLM is in general at all the direction you want to pursue, or perhaps combining your large language model with additional multimodal or dynamic knowledge source. Now to a more practical side of things in terms of playing with those models as a user or trying to prototype, yeah? This is something we can do with the help of so-called prompting or prompt engineering. And on the surface, natural language interface offered by prompting seems to be like too good to be true, right? It's an ideal gap between AI experts and lay people, because most of us know at least one language, and we do use it with communication, so we might just do the same and use it for communication with the large language models. But prompting is a fine craft that we don't fully understand yet. And successful prompting that goes beyond the trivia of trying to guess the right mix doesn't only require strong linguistic instincts, but also knowledge about how large language models work. If you are the type of people who like some homework or try to dig into the topic, here are some interesting sources that you can look into. The first paper outlines the usual pitfalls of people trying to fine-tune the models via prompting. And then in general, with the prompts, we can see a lot of different approaches to them emerging, right? We can see a prompts marketplaces where you can just buy a prompt that somebody else created for a task for a couple of dollars and then change it for your own purposes. You can try this way. You can try learning and understanding the way how to craft a prompt, but I think we can also expect the user interface of large language models to change a lot in the upcoming years too. So it might as well happen that the next edition of GPT would just, have the toggles and sidebars instead of the actual text input. So investing a lot of your time and energy into getting one of those brand new master degrees in prompt engineering might be not the best choice. There is one resource I specifically like, not only because it's open source, but because it's very dynamic. It's called learnprompting.org. On the right, you can see sort of a thematic interface that's there, and this is something that's being continuously built and improved by the community of practitioners. It offers a bunch of learning paths where you can start from a very basic introductory level to the more advanced requests you might have, like prompt tuning or prompt hacking, trying to work around the limitations of the models with prompts. So definitely look into that. For those of you who have no idea what I was talking about when I was talking about prompts, here is a quick detour, right? You usually interact with the chat interface of a large language model by putting in a prompt, a textual query, which can be a question or a request, and you get an answer out of it. However, when you are structuring your prompt, you can approach it with all the creativity possible. One of the approaches that has proven very popular with the older GPT models is role prompting, where you use essentially role play and assign to the language model a role of somebody that you want to interact to. And on a very simple level, it can be like, yeah, generating something that looks like Shakespeare. But this can be also extremely useful when you are, for example, preparing for an interview and want to assign a role of be a recruiter in a technical company in this specific domain, and let's have a conversation when I'm trying to apply for this role. Give me challenging questions, let's have this interaction, right? You can use this, and I've been a witness of a few exciting sort of trial use cases of using the publicly available ChatGPT interfaces for the onboarding of new employees. Because when there is a limited amount of knowledge of input data that are sort of the answers to the frequently asked questions, you can put, if you're coming from the business side, you can put your new salesperson to interact with the model and give it a task of playing a role of a challenging customer that wants to challenge your salesperson, right? So this is generally useful for education. An approach that's called few shots prompting, similar to few shots learning that we briefly discussed in the beginning, is about giving more examples, giving more context for the model output. And that's one of the approaches of how you can make the output a little bit closer to what you actually expect. What else is useful to know is that perhaps you can experiment with the output formats too. With the ChatGPT interface, you can directly request it to give you an output in the form of an Excel table, for example, sorted by a certain parameter. One more thing that I want to give you the inspiration for today is that if you try to be a bit more creative and look into the ways how to enrich your prompts with some educational techniques that are not maybe obvious from the first try, it's actually a very, very fun thing to do. The Feynman technique, which is about, if you're all on Reddit, right? You all know explain it like I'm 5, so this is sort of a thing you can try to do with the large language models. Try to get it to explain a new concept to you in a simple terms. Ask it to generate a series of challenging questions to analyze how well did you understand the topic, review and simplify, and on and on. Additional inspiration goes to the Pareto principle, which is also sort of a black box, right? It's a notion that 20% of effort is usually accountable for 80% of results, but we never know which exactly, right? So it's actually a fun thing to combine those two black boxes. And again, back at home in Czech Republic, I know a very successful venture capital company that's now using that in a form of just prompting with the ChatGPT to try to work on analyzing new markets and the potential of new products. So give it a go. It can be helpful in anything from trying to create interesting stories to make you learn something better or to generate a bedtime story for your kid. I am guilty. I have a small daughter and I don't always have energy to generate interesting stories for her. But when I want to do that and incorporate some Easter egg, as in the main point of the story being vegetables is good. This is also large language models are also, the thing that you can go to. Now we're also looking at the integration of the text language models and the visual language models. So you can essentially even get, the illustrations for those stories if you'd like. On a more practical way, if you're looking at trying to play with these interfaces for your company, this is an actual factual scheme of using and integrating GPT interface for a marketing agency that's operating in Czech Republic. They use something called AI assistants. There is also a marketplace of those. Those are like a little bit pre-trained GPT-based tools, which you can use to work with a database of leads to process them, to give them to the marketing manager, which will then task the AI-driven copywriters to create specific personalized types of text for each lead. Send it back and then see how they respond, how they react. Yeah, so the potential for that is generally huge. There is a lot of those applications hiding the simple API under the hood and doing interesting things. Three of my favorites that I just wanted to share out of the top of the head, the practical use cases where you can start using it right now, are the applications like Otter AI, which act as the transcriber of your video calls and video meetings. You can just plug them in on your Zoom call, you get a transcript, you can get a summary of your call, and even connect it with the further automation tools like Zapier to actually do stuff that follows up on it. There is a lot of tools that leverage the ability of large language models to generate the summaries, and the PDF, GPT, or chat with PDF, anything you'd like to use, are the tools that enable you to load up a complicated contract and actually chat with it as in, when does this contract expire? Or like, what do they mean by this and this and that? So this is a very practical way to use that. Yeah, so to sort of sum this up, I think now in the evolution of our productivity, we're standing at the point where the first thing we can start doing when interacting with large language models in our everyday life is using those AI productivity tools. Still, it requires a lot of our internal discipline and skill to outsource things, to delegate things, because that's what I think we're actually not ready to do, to define that the task of transcribing the meetings and making follow-ups is something that I don't want to do anymore, and I'm ready to give it further to the tool, right? If we want to go further and go under this black hood, not only to outsource our tasks, but to actually improve ourselves, to become more relevant, to stay in the context, we can use AI tools for learning, for explaining different contexts, for having more personalized learning path. And we can see, for example, Duolingo or Khan Academy doing very exciting work with integrating GPT-4 into their learning mechanisms. Further on this imaginary stairs of self-development, I put the AI-powered self-development tools, the AI-powered chatbots that allow for coaching, for the self-improvement. That is obviously very personal and delicate to everyone, because that requires assuming the notion of accepting the feedback from something that is not human. This feedback might be objective and might be useful, but that again clashes with the notion of trying not to put personal details into the models which we don't exactly know where they are coming from, right? I have a couple of minutes left, not really. Okay, I will just jump to this slide as sort of a conclusion, because what you are seeing right now is also a lot of discussion about generative AI taking jobs, replacing certain professions. And I hope after hearing all this, you realize that just by the way the systems work, this is really not the case. But the people who use large language models for their productivity are likely to be the ones that are more, in a better position on the labor market, as opposed to those who don't. And increasing the labor productivity in general across the market will require significant investment to support people retraining, and the willingness of us as a people to do that. Because what is clear now is that all of us are doomed to learn continuously throughout our whole life, to be scrolling those news and seeing the new architectures and new models coming up every month or two, and learning how to make the best out of them for our advantage. Thank you very much.